All right, appears to be live. Do the usual testing and such to make sure that we have audio. All right, appears to be live, and we do. So everything seems okay. And what window do we want now? Comments hopefully will show up here somewhere, and I will hopefully be able to slide them over here. And very good. But one of them isn't showing up, unfortunately. So somebody made a rag about Maxwell's equations. That's also in this comment, so I might as well just open this one up. And so I thought I'd go over some just the basic, what I mean by when I mention Maxwell. Maxwell basically took a bunch of observations by Gauss and Lenz and Ampere and somebody else, and he basically took all of their little equations and put them together in equations that were a little more connected to each other. So connecting the idea of charge to the idea of magnetism. And so, I mean, I could mention each individual thing. I could say, well, here, this is consistent with Ohm's law. This is consistent with Ampere. And this is, I could do individually, or I could just say, look, there's a package of formulas that basically explain how the radiation from one thing, a wire, gets to something else, like a magnet, or vice versa, and what are the rules for how that happens. And my argument is that my theory is perfectly consistent with any kind of illustration or drawing or any way you could explain what those formulas are indicating, the proportional relationships, why they exist. So I'll explain one system and just see where that goes, and just explain how my theory explains why the phenomenon exists, where their theory doesn't. Kind of glaring. Anyway, yes, so let's, I suppose, find the other jerk's person's comment. I think it would be here. Okay, so this comment doesn't appear to still be showing. I would pay you money in order to hear you explain Maxwell's equations. Okay, yeah, I don't. Obviously, some of it is time derivations. I mean, they're obviously, if you're going to explain how much energy happened, you have to explain, like, you could move something really fast, you can move something really slow, and there's going to be a different amount of energy. And that's what some of these equations are talking about. So obviously, those are kind of complex equations that are approximations. I mean, there really are just approximations. That's sort of the nature of integrals, is to make a very good approximation, the best approximation you can anyway, the best available approximation. And I don't think there was anything else. I'd pay him money to explain the Albert operator and how Maxwell, I looked up the Albert, gets into like when you start adding Einsteinian time relativity crap and all that, stuff that doesn't really matter, stuff that nobody in the real world ever uses, stuff they don't even bother to use, and NASA doesn't even bother with the old D'Albert operator. So it's just horseshit. That's very convoluted math, and it might be a tiny bit more accurate, but it's accurate. It's getting the right answer for the wrong reason. The equation is a formula that has somewhere in it some connection to the truth, just like Einstein's formula talks about some sort of time dilation factor. But what's really in the math is the movement of the center of the sun's gravity. So you can talk about it being time dilation, but it's not really. It's just the movement of the sun's mass. All right, anyway, average mass. So this one I'll read. Why would anyone slave their time away trying to show you that your anti-drag diagrams don't work? Well, let's go ahead. Fine, you're just saying I can't be bothered. Fine, don't be bothered then. I'm just saying until you do actually make an argument, the argument stands. And again, your theory doesn't explain at all, because you pretend you have a non-existent ether. You just make magical dark matter. It only makes gravity. It doesn't do anything else that matter does. So you make a catch 22, 24, 25. You just make catch physics, where you create invisible men to do invisible work, and you don't have to take any accountability for what the real consequences would be if you made it out of something called physics. You make it out of fantasy characters, little fairy godmothers that come to the rescue, and it doesn't cost anything, and nobody has to put her in a house, and nobody has to pay her Social Security, and yeah, it's all free. Anyway, it would take hours just to explain the simple point. Why would it take hours? You know, just retarded that it should take anything but a simple argument saying that somehow you can't do that. You know, somehow physics requires that, you know, all the energy stays in the system, and there's no way that a mechanism could be created inside an atom where it actually releases more force in one direction and therefore moves in this direction. Yeah, it could actually create some sort of little rocket engine. Yeah, it's possible, asshole. Because you never, ever want to understand or comprehend unless it's a simple, snappy sound bite. Well, again, none of these videos are made out of sound bites. They're, some of them, you know, complex drawings. Some of them are, I mean, there's some detail to it. As I've stated, physics isn't simple. There's lots of things that fit in the category of physics, lots of phenomenon, and tying them all together is a lot of work. So fuck you. If you can't be bothered making the argument, then just concede the argument, okay? But you can't just pretend, I have an argument, but I'm just not going to make it. That's just garbage. Someone already pointed out to you, no one pointed out anything, in the latter half of Talk Physics, Light Relativity, that you contradict Gauss's law. Well, there's nothing contradicted. So again, back to this inverse square law. The point is Einstein doubled the force of gravity. That's the point. Now, whether or not it's a changing of the inverse square law, which is more than a doubling, you could argue. Obviously, it's a square of the radius, but I'm just saying in some circumstances, you could argue that doubling the mass of something would be the same for some positions as removing the square off the r in terms of how much radiation you're creating. But regardless, we've already been over this. The fact is that Einstein creates a special formula just for photons. That's the fact. And it seems like you're just belligerently ignoring the point of the argument. Okay. In electrostatics, and keep misunderstanding the comment over and over and over. No, you keep misunderstanding. When you change a 2 to a 4, that's a doubling of the mass of the sun. That's what Einstein did. He said for photons, you can double the mass of the sun. Double it. I mean, you're just such a liar. I mean, I've said that over. Again, I'm not going to revisit it because I made an hour's worth of video on it already. This point is not complicated. On the other point, gravitational aberration has nothing to do with the core at which the shadow is created. Well, again, unless you're going to explain what it has to do with, because again, you keep saying my theory says stuff can bounce off at weird angles. No, I've made it as explicitly clear as possible. There's only direct reflections or 90-degree angles, but there is no other absorption. I mean, I said it over and over and over and over as a definition of the theory. You want to keep saying my theory says there's a bunch of little meteors and they bounce off in all kinds of weird angles and then the round surface will cause... No, that's not my theory. That's not what I'm arguing. So you want to keep putting my theory into your pigeonhole, and it's a lie. You want to keep perverting it into something you think it is, not what I said it is. You liar. Oh, God. You misunderstand that. Well, no, you misunderstand what it is to be a decent, honest person. You're a preposterous distorter and liar. Okay, so unless you are going to argue my theory, not Lesage gravity, not somebody else's theory, my theory, fuckhead. All right, physics doesn't work through sound bites. Well, again, only an idiot would say my video is full of sound bites. That's just retarded. I'm not going to bother engaging in that petty shit. Sorry. Well, I'm not going to miss you. And again, your argument is vacant. I have an argument, but I'm not going to give it to you. Well, then fuck off. I mean, I won't block you, but you're not going to get anywhere. I'm not impressed with your non-argument. And so clearly you're just using it as some sort of telling everybody, hey, wait a minute, we have arguments, we just can't make them. Which, of course, I give you the opportunity to make them and you don't. And then you tell me I have to let your crappy comments stand, even though you didn't make an argument. You're just creating a distraction. And that's all you intend to do, because that's all you have. You're just going to wave your hand saying, no, 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 it's not the truth. It's like you're standing up in a courtroom saying, no, 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 that didn't happen. That's not a fair piece of evidence. No, no, no. But you don't have any argument. When somebody puts you on the stand, you have nothing to say. I'm not going to be bothered with this. This is a sham process. So you're just making a scene to try to deflect the fact that I made a perfectly valid argument, and you're trying to say somehow it's not valid without providing any evidence that it's not valid. That's bullshit, fella. You know, I ain't playing that. All right, so I thought he had a little more Maxwell stuff in there, but apparently there is no other Maxwell stuff. So that will give me, I'll just deal with the other guy who made the Maxwell arguments. That somehow, I don't know what Maxwell was talking about or how it works or blah, 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 and I have no right in some way. So Maxwell drew a ton of diagrams of charge, just as I've pointed out, like you have 4 protons over here and you have 1 electron over here, and it would be this argument that from a distance, there's basically a 4 minus a 1 or a positive 3. But as you get close to the electron, all of a sudden the electron dominates, okay? And now this repulsion is stronger than the 4 protons over here because of proximity and the inverse square law. So it's like a gravity argument. You know, when you're on the Earth, the sun's gravity is irrelevant. But if you're floating in space, the sun's gravity is really relevant. So it's all about the proximity, because the force gets much stronger the further away you go. I mean, the weaker the further away you are from it. So when you're close to something, it's going to dominate it's going to be the dominant influence. And when you're far away, you know, that can change radically. Who's what you're seeing. So from a distance, say if it was red and black, from a distance, you're going to see red. When you start to get close, it turns black. No paradox, just the way it works. So this is all kinds of Maxwell stuff. Field lines and the rest of it. So solenoids are kind of interesting. So I just thought I would do some of that. I'd use that as a foundation for an argument. Let's see, is there anything I have to get here? Let's see. The problem is that you don't know enough math. That's Hillary Clinton. Isn't that cute? The cowboy, no doubt. I guess I'll just read the comments and then block him, and then I'll delete all this rubbish. It's just obviously just rubbish. The math is just a formalization, again, of relationships. The fact that you could write up a mathematical equation for adding water to a bucket, and you would recognize that the volume of the water is proportional to an increase in the mass of the bucket. That's all it is. There's nothing incredibly special about mathematics. It's just a way of taking relationships that exist, proportional ones. Yeah, I don't know how else to. Relationships, and just formalize them. That is, give them direct proportionality, plus, minus, equals. And that's it. It's not voodoo. It's not some magic that you have to go to magic school to learn. I mean, obviously, the methods that they can use, the tricks, as Feynman would say, the tricks. There's a big list of those, a big bunch of those, and they're very useful. So knowing how to do all the little tricks is important, but it's not the math itself. It's not the foundations of what mathematics is doing. Mathematics is just recognizing a relationship and drawing you a plus and minus picture, taking a scale and putting weighted numbers on it, like the numbers weigh 1 ounce, 2 ounce, 3 ounce, 4 ounce, and just showing you the proportions. It's just showing you what the circumstance will indicate. That if you have a 2 over here and you put 2 1s over here, that the 2 will equal each other. I mean, not complicated. Look at all these comments. For what? I haven't started yet. What you talking about? Okay, we just fucking say goodbye to you. I guess is there any real point? Let me think. Is there any real point in anybody who comes into a room and says, "What you talking about?" Is there any real point in that person participating in any way? No, there really can't be. It's too ludicrous. Hello, I'm special. Start over, and tell me everything that you've said so far. Now, that person's too retarded, right? I mean, there really wouldn't be any point in me tutoring that person on how to live like a fucking reasonable human, right? Because they're totally not reasonable. I mean, they must have, like, tissues from when they wipe their ass in their pocket. And if you met them on the street, they smell this. They're fucking retarded. So anyway, let's see. A rocket engine goes off exhaust. You can't get something for nothing. And no one said it was for nothing. So, but go ahead. Say stuff I didn't say again. Go ahead and say it. I'm saying the pressure exists, right? So if there's pressure in a balloon and you open an end of the balloon, well, then the pressure will go out that end of the balloon, right? And let's say you're pumping the balloon up from all directions, but you're only letting it out one hole. Now, wouldn't that be the same thing as an engine? All right. This is why no one bothers to argue about your drag. This is so stupid. Again, a non-argument. What's your counter-argument? You don't have one. That comment is not talking about gravity. It's how far off this idiot is. So you can't post a link. You don't know what a link is? And the comment section allows you to post a link. I mean, I'm not going to go fucking search in my videos to go find out what reference you're talking about. What is it talking about then? If it's not the inverse square law argument about gravity, then what the fuck argument was it, jackass? God, this has to be that fucking idiot, that mindless shit fucker. That's no argument. Another perverting of the other's argument. So in more crap, he's saying this live to whatever I was saying as if, that's some fucking way to argue. He's not arguing a point. Just such a waste. Same to you. Brilliant. The arguments have been given. No, they haven't. You didn't even comment on anything close to a reply. What was there to reply to? Nothing in there. All the videos are public. Again, once I'll state, I haven't deleted anything. If you have some argument to make, as I stated, I will post it on my channel page if there's some fucking brilliant argument you've made somewhere. But there isn't. You're just saying, that's not true. You're not explaining how it's not true. It literally referenced a video where someone made an argument. You didn't address it. Bullshit. Okay, that's only further proves how pointless all this is. Okay, then just fuck off. I mean, you didn't make a single sentence here that had any meaning whatsoever. Nothing. You said absolutely fucking nothing. It's a waste of goddamn time. All right, so to the coil. All right, so black as shit. Do I have another black? Well, maybe we just use blue. blacks are drying up, I guess. Oh, gotta put that camera on. Thank you for remembering, Gary. All right, so yeah, that's good enough. All right, so turn it this way because apparently the camera's a little fucking distorted. Anyway, so coil of wire. All right, so Maxwell's equations covers this kind of circumstance. You put a current through this coil, so you have a plus and a minus. And the plus and the minus is significant in the sense that there's going to be a direction, and they always draw it like there's little arrows shooting out, little arrows going in, little arrows shooting out. None of that's happening. The arrows are just an indication of what kind of magnet it's creating, whether it's creating a north-south magnet or a south-north magnet. But that's all the arrows mean. The arrows don't have anything to do with something actually moving, except when you're talking about arrows indicating which way the current is moving. In this case, which would be from positive to negative. They always do current backwards for whatever reason. But anyway, so the field is created. So you charge this up with DC current. So let's understand it's DC current, not AC. And what you'll see happen is just about nothing here. So you go around the outside of the coil with a compass and you'll get no indication of charge. So it'll be no charge out here, no magnetic field. But inside, yeah, just like these arrows lines, there's a field, okay? And the field means not that there's lines going this way. It just means that if you put a compass in there, the compass will do, what compasses do, which is it will point north to south, indicating which way the magnet is oriented in a sense. So if I put the current the opposite way, plus the minus, the little needle will flip the opposite way. So, but there ends up being a substantial charge in here. Now, Maxwell's equation basically quantifies how strong that charge will be based on how many loops are in a distance. And there are certain assumptions built into that, which essentially the assumptions are you didn't leave any airspace. So the loops are tight loops, okay? Because loose loops won't create the same scenario. But the point is there a proportional relationship between how many loops there are and the distance. So basically indicating that, first that the wire is producing the effect, and second, fix my image. Yeah, so, always some little technical problems. So it's just recognizing that proportional relationship. Now, what my theory explains that their theory doesn't explain is why this phenomenon exists. Now, the fact is there is a bunch of charge, okay, that's coming out of the wire. I mean, a bunch in the sense that the wire is producing a magnetic field on the outside here. It's not nothing. They just like to say it because it's so insignificant that for no circumstance does it mean anything. But it does exist. It's just very weak. And the difference is on the inside, it's very strong because it's constantly reflecting. So if we draw another picture of the wire from a different perspective, so now you're looking through the loops of wire. Plus, minus, whatever. What's really happening on the inside here is that this wire is in fact becoming magnetic. So while the current's flowing, there is the electrons on, say if you had a piece of wire, the electrons and the protons are lining up. So you're ending up with a lot of basically building a magnet. Plus, minus, plus, minus, plus, minus. So when electrons are moving, that means the atom is essentially being polarized. So the atom could be just normal, let's just say little stuff orbiting, stuff in the middle. And then while there's charge moving through it, the atom changes its shape, if you were to make it that simple an argument. And now it is distinctly polarized. Okay, so it's now making what you could understand to be that row of little magnets. Okay, little magnets going on and on and on and blah, 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 blah. Just like how you make a real magnet by putting a lot of little magnets together. So in a sense, this entire inside, see, so on the outside, the same thing is happening, but all the radiation just flies into space. So that's it. It happens and it's gone. It just radiates into the environment. But what's happening on the inside is it's perpetually reflecting. That is, it just keeps bouncing back and forth and back and forth and back and forth because it's hitting a magnet. And the magnet means that if an electron bit, hits the proton bit, the red. So I don't know, I guess I probably should draw that more legitimately. So there's a red end and a brown end. Okay, so if a brown bit hits the brown bit, you can sort of understand that's a reflection. Okay, brown bit back out. So that's going back and forth. And if a brown bit hits the red bit, it goes perpendicularly, which means it goes into a brown bit. Either way it goes, it's going to be a brown bit. And the brown bit, okay, will reflect it back into the red bit, which means it'll come out perpendicularly from the red bit. So it comes out again. So all the energy, all the force just keeps bouncing back and forth. And the only force being lost, that is, oops, so it just keeps reflecting. Yeah, that's sort of neat. Yeah, should get the big magnifier. Yeah, that might be a good idea for the future. To be able to zoom in mechanically. All right, so what's happening on the end of the coil is the tricky part. See, so if it has air in it, you can see that if the coil has air gaps, yeah, then this force would escape through the air gaps, and it's going to be a lot less effective. But if you have it well round and then wound even layers of windings, well, then you're assuring the fact that none of the inside force can ever get out. But it'll clearly, because of the way the force radiates, which is in a spherical manner, the ends is where it can escape. So that's why it doesn't become perpetually hot or something. That's why, as an engine, it can't hold perpetual energy in the sense that it just can't get hotter and hotter and hotter, or more magnetic, more magnetic, because it will escape out the ends, so to speak. So eventually the force does get out, but it doesn't get out until it's reflected 500,000 times or something. So it stays inside very long and does much magnetic work while it's inside. So when I say my theory fits Maxwell's equations, that's what I'm saying. My theory is perfectly consistent with what's observed when you create one of these circuits. It fits the facts perfectly. So the other thing you can do is, let's see, you can create a coil of wire, and this one's, it's important with the solenoid one that it'd be the longer the coil is part of the math, right? So it has to be longer than it is round, or it won't work. And the reason why it won't work is, you can sort of understand, is if I make a little short coil, if I make a little stubby coil, the odds of the stuff getting out, it'll get out a lot easier. So the longer the coil is, the more likely you're going to create a lot of reflections before the force gets out. So you have to understand, it's bouncing around inside of there. It's not bouncing back and forth, straight back and forth. It's bouncing this way, this way, this way, this way, this way, this way. It's going in all kinds of directions because it's being emitted in all kinds of directions. Spherically, like a light bulb. Some of the rays are going this way, some of the rays go this way. It just depends on what position the electron's in, which way the ray goes. Okay, so the other experiment you can do is put a bunch of coils together. So this illustrates more like Lenz's law or something. So you have a bunch of coils, very short solenoid. And so it's not really a solenoid anymore. But anyway, and you put a voltmeter on it. You know, just draw that like that to measure the voltage. And then you stick a magnet into it. Okay, so then you take a magnet and stick the magnet in. Now what's going to happen is the magnet is going to basically start affecting those atoms again. So the atoms on the surface are all regular, relaxed, so to speak, in their neutral position. And when this magnet starts approaching, what's going to happen is they're going to start doing that thing again, where they're going to start stretching or deforming into little polarized elements, because the electrons are going to start being essentially pushed in a direction. Either you're going to be pulling them this way if you have the red end one way and the black end the other way, or they're going to be pulled in the opposite end. So depending on which way you put the magnet in, again, will decide which way the current needle moves. If you put the red end in first, then the current needle moves one way. You put it the other one, it moves the other way. Now, obviously, it has to be moving, because only when you're pushing electrons, okay, that is, only when the electrons are being hit by a force and being forced to essentially jump locations, are you creating a magnetic surface. So you're creating the magnetic surface. The magnetism isn't coming off the electrons. The electrons aren't excreting it. The protons aren't excreting it. It's, again, the gravity argument. The gravity, it's a magnetic surface you're creating on the conductor. You're causing the conductor to create a bunch of polarized atoms, a bunch of little magnets. And the more current you put in, the more little magnets you're making, because all the atoms have to bend to get rid of their electrons in a direction. And the direction is going to be dictated by which way you push them. Okay, what end of the magnet, what way you push them, attractive or repulsive. And it's only going to happen while they're moving. So as soon as you stop moving the magnet, the atoms go back to their normal state. And in some sense, still recognizing that they're going to have a bias. Okay, so you have pushed pressure to one end. So if you didn't put any way for the magnetism to get, the electricity to get out, you would charge this wire in the sense that there would be more electrical potential at one end than the other end. That is more pressure. So they wouldn't completely relax. They would just relax in the direction of the current, because there's more pressure. Those electrons can't get back. So that's why when you push the magnet in and then stop, everything kind of just goes back to relaxing, because it can only be when you're moving the electrons that you're stretching the atoms. So all the atoms stop stretching and just relax in this new position. So, it just essentially relaxes, and these electrons at this end would be closer together. So there would be more positive pressure, you'd say, more pressure. Well, it's actually negative if you want to be accurate about it. And there'd be less electrons at the other end. They'd be further apart. So there's still a charge in the wire. There's still a capacity to draw a little bit of current if you wanted to. But that's all there is. There's just this much. And because you're not letting anything relax again, that is, you're not letting this depressurize, you can't repressurize it. And so you have to move the magnet. So that's why you have alternating current. It makes a transformer work, because you're basically keep the electrons always moving, which means the surface is always magnetic, because electrons are always moving. So the atoms are always distorted. And again, this has to do with the volume thing, as I was trying to get to. The current is obviously, the more current means the more atoms are involved in the process of moving the force, the pressure. And the more atoms you involve, that means the more little magnets you keep creating. I got to come up with a simple non-colored way of making these little magnets, but you know, each atom is a little magnet. When you pile the little magnets together, you make a big magnet, and that's all that's happening. You're just making a magnet. So the force that you're creating a voltage, and you're going to create a magnetic effect, but the magnetic effect again isn't coming from off the voltage. The voltage isn't producing it. The magnetism, the fact that you've magnetized the surface, is what's creating the magnetism, and therefore the same thing also happens inside this coil, that the force will reflect inside the coil. But obviously, because it's such a narrow coil, a lot of it escapes. So anyway, so that's what I mean by it fits Maxwell's. Maxwell's equations give you a mathematical way to proportionally understand how much current will bend how many atoms and cause them to polarize, and how much magnetism you'll create. So it's just math that explains exactly what I drew here. All right, so that's what I mean by this theory is perfectly consistent with Maxwell's equations, and that the product of the equations, the variables in the equations, are exactly what this theory illustrates why it's happening. What's happening? Whenever there's magnetism, it's not being created by the electricity. It's being created by the deformation of the atoms. They are arranging like magnetic bits. They're little magnets. The atoms are being turned into little ferromagnetic bits. And you're just making a magnet out of something that wasn't a magnet. And the more current you put through the right conductor, you're making a very powerful magnet, because all of the atoms can be made magnetic just by pushing the current through and forcing the atoms to be all in the same alignment. All right, I think that's probably good enough. All right, so we'll see if there's anything here. Trolls, old style AM radio antenna. What does that mean? Jeez. Hi, useless. I'm visiting random live streamers. Oh, who could care? You really think you're so important? You sound really smart. Whatever, fuck off. Don't bother blocking, but Jesus, how useless can you get? Jesus, I'm important. Pay attention to me. Oh, God, people. I mean, I wouldn't even imagine that I would type something like that ever in my life. All right, if you use magnet, you will create gravity pool, don't you? No, whatever that crap is. If you use magnet, you will create gravity pool, don't you? No, garbage. You've got to be able to find a better translating software than whatever you're using. You doing something wrong up there. You've got to do better than this. Sorry, time out. Can force get tripped in the coil? I guess he meant trapped. Exactly what I said. Yes. If you put two magnets next to each other, all right, the same thing is happening. The repulsive force you feel when you put two magnets the same direction next to each other. You feel all this pressure. It's pushing, saying, I don't want to be close to each other. I want to be, it's pushing. And it's pushing because of this reflection thing. It's just direct reflections. And those magnets are perfectly aligned. See, the magnets in the conductor are probably a little bit skewed. Okay, they're pointing this way or pointing this way. So they're probably a little bit sloppier than the perfect alignments in magnets. But still the same effect. It reflects off one surface, then reflects off the other, then reflects off this surface, then reflects. It doesn't get out. It doesn't stop hitting things. So it's like a ping pong ball trapped between ping pong paddles. That's what you create when you create a solenoid coil. You're creating a place where the force just can't get out until it bounces to the end, and then it can get out. But otherwise it can't. And all the negative force does go one way, the black force, and the red force does go the other way. All right. It just still seems mysterious, whatever, how an object not in physical contact can affect another. Well, I mean, it's a pretty, I mean, I don't know how you can say this any simpler, but I mean, I'm basically overtly telling you that a photon is a physical object and it physically contacts you. So if I throw a baseball at your fucking head, you're going to say, I, personally, me, physically contacted you, aren't you? I mean, if I write fuckhead on the baseball and throw it at your fucking head, aren't I physically contacting you? The little bits from the magnets are exactly like they're baseballs. Electron baseball, proton baseball have different rules, so you can call them baseball, tennis ball, I don't care. I mean, there's different rules. But it's so simple. It's checkers, just black checker, red checker. They're the same checker. They're just red and black. They just have one little property that's different. You can't get this? All right. It's a change circulator, a charge circulator. Well, I guess you could. Well, I don't know why you need to call it, something else, but okay. So the simple arrangements stimulate magnetics. I think I pointed it out. When you move an electron, okay, not free electrons, but electrons that are somehow bound to atoms. When you do that, when you hit one and it's still connected to a proton, it stretches it into a dipole. See here, when it was an atom, it was neutral. But when you stretch it, because you're pushing the electrons away from the proton, you're stretching it. You're creating a little tiny magnet. And when you put a bunch of little magnets together, it becomes a big magnet. Thank you for the food for thought. I don't like fromages. All right, skip the comments you can't handle. It's not about handling something. It's just about rude and stupid, and the fact that you can't do anything but be rude and stupid, and you're doing it in this obnoxious way where somebody politely says, look, we just fundamentally disagree. We don't agree on a single fucking thing on this planet. So why don't you just leave me the fuck alone? I'll leave you the fuck alone. But you don't want it that way. You want to stalk this fucking channel and be an obnoxious fuck. And shit, you're revealing a lot about you, except you don't even have the balls to show your fucking little weasel face. You're such a fucking coward. I mean, what an amazing thing. It reveals a lot about you when you don't even have the courage to sit there and put your real humanity on the line. You're a coward. Does your cowardice know no love? Yeah, obviously, I'm just saying, obviously, people can see who's the coward here. The anonymous troll, or the person who's made 1,000 videos in your face, with his face. Dr. Willie versus Proto Man, XXX. I don't know what that means, so I'm going to time out you, but I probably should just block you for typing something that doesn't mean anything. I mean, why can't you people do a little better than this? Tripe. I mean, why is tripe all you have? All right, so let's do a couple of the Hillary Clinton comments and we'll be done with it. I mean, it's just I'm just not going to. It's obviously just trolling in this obnoxious manner. I mean, how many comments? He talks about cowardice. He can't even figure out the civilization idea that you don't sit there and steal all the napkins at the Dairy Queen or something. You don't pull all the paper towels out of the bathroom dispenser. I mean, you just take your share. But he can't even figure that out. He's such a fucking caveman. All right. Thanks. Didn't mean to put words in your mouth. Just possibilities comprehend. Well, I could have just stopped at that part of the sentence was nice. Just possibilities comprehend doesn't mean anything. All right. Anyway, what about your dick? Yes, you are. Now it's time for you to look up the generic fallacy, whatever is magical fallacies. So it's not. So he's insulting somebody else. So let's see. Inside that chest beats the heart of a true scientist, my friend. Well, whatever that. I'm not really looking for that kind of grandiose crap. But there's obviously people who are, who are puzzle solvers and people who aren't, I guess. But anyway, you say been playing with physics for the last 7 years. I'm playing with it, but whatever. So Einstein was doing physics since he was 6. Well, all of it wasn't physics. I mean, solving mathematical equations isn't exactly doing physics. Until the day he died. Yes, let's understand, 2 days before he died, he said, I spent 50 years analyzing photons and I haven't increased my knowledge one iota. So I'm just saying that's his failure, right? I have increased my knowledge one iota. So yeah, just luck of the draw, I guess. He couldn't find the trick. I found the trick. There, that's the difference. What the hell do you expect? Whatever that is, it doesn't even, more of this meaningless mush. It's not even a, whatever. Let's see, there's absolutely nothing wrong with the universe being fundamentally probabilistic. Except for the fact that it's a complex function, and you have to explain where a complex function comes from. So whatever, you can believe that things come from nowhere, and they do so in some organized way. Not random, but organized. Fine. I think that's just silly. So it goes against your pig-headed metaphysical bias. So it's a metaphysical bias to not to be a metaphysicist. Yes, I don't believe in metaphysics. I believe in physics. I believe there's physical objects that do physical things, and there's a cause and an effect, and everything else is just nonsense. Do you really need me to tell you that's not an argument? I don't need that argument, frankly. My theory doesn't say anything about the existence of God. If you want to believe in a God, you go ahead and do it. It doesn't say anything about where the electrons come from, where the protons come from, or where the force comes from. It doesn't need to argue that. The universe has obviously had these things in it for a very long time, billions of years, and there's no evidence of fairy godmothers or any of this crap. So I'm just saying it's pretty clear. The stuff that's been here has been here for a very, very, very long time. And I'm giving you a theory of how it functions. The stuff that's been here for 13 billion years. I'm not explaining creation. It's not my theory, faggot. Okay. As far as testability goes, your theory doesn't fare any better than string theory. Well, I'm just not reading the rest of that because it's just obviously nonsense. It obviously explains magnetism, which string theory doesn't explain either. So again, it's just such a lame on its face asshole remark when the fact is your virtual photon explanation is rubbish. And my theory, my explanation isn't rubbish. It's completely fits the evidence and explains why the things move. As my gravity theory explains why I move towards the center of the Earth. Their theory doesn't explain where the energy comes from. All right, I will be watching you, kiddo. I'm going to read the rest of that either. You need to actually explain double slit. I've already done this double slit experiment, so fuck that. This is getting seriously out of hand. Occam's razor is not the only metric by which... Okay, so I mean, I basically said overtly, it's one of the things. The fact that my theory unifies, that's a point for its side. The fact that it unifies with a simple checkerboard explanation, that's a point for my side. Yes, they're all evidence. Each little bit of stuff is a piece of evidence. Shit. You can't do anything called thinking, can you? Oh, man. What an idiot. All right, so fuck off. Oh, it's just so slimy. People who steal other people's names. It's just so slimy. Ew. Phew. All right, anyway, so let's see if there's anything else, and then we'll be out of here. If anybody has any comments to make, relevant comments, put this back here. And let's see, maybe yeah, this is a good enough drawing. It's a coil, so you get the idea. That's what I was talking about. Yeah, it has little stretchy atoms here. It has force trapped inside the center. It keeps reflecting. Let's see. Visualization is key to processes. You don't understand how that sentence is just rubbish too? I mean, you could have said key to understanding. You know, you have to have an imagination. You have to be able to model things, to see it, to understand it. You know, that could make some sense. But this drivel, the he diagrams help to see what is happening. Yes, that's a little better. Diagrams are helpful. That's right. That's why I draw them. That's why Maxwell drew them. And my argument is that my diagrams match Maxwell's diagrams. The same diagrams get drawn. My thing does exactly what his stuff does, except these arrows don't mean there's anything moving inside of that coil. There really isn't anything moving inside the coil in that direction, so to speak, except the fact that over time, you know, if you push something at an angle, you know, obviously you're moving it, all right? But the stuff itself, there's no flow in there. There's just a movement of magnetism. The little magnets are moving. And it's clearly completely the electric current is, see, they should really make an association. They really should just nail it down and say, look, we're just going to put a minus sign on the north end of the magnet and a plus sign on the south side of the magnet, because that correlation exists. You put the magnet in one way, the compass needle flips one way. You put the magnet in the other way, the compass needle flips the opposite way. Clearly, there's this huge association, huge connection between the direction of the current and the orientation of the magnetic field created. Now, the field induced is exactly the opposite, so I didn't get into induction. But maybe next time. Let's see. Faraday drew them also as well. He looked at the coils himself. If you asked him how it works, he'd stick a cattle prod and tell you that's how. Yeah, well, that's like Newton. You know, I don't tell you why. I just tell you what happens. You know, that kind of. That's fine. I'm just saying. Clearly, there is an explanation, and I'm giving it to. I'm explaining to you why this weird. Oh, how come there's no charge on the outside and a ton of charge? I mean, a ton of magnetism on the inside. Well, it's because you've trapped the magnetism. Even if they think you're, I mean, this is the whole reason why I don't want to get into math, but there's a thing called a Gaussian surface. So if you want to find out how much charge is in a location, you create an imaginary surface around it. And it doesn't really have to conform to any shape. It just has to enclose the thing. And what you're basically doing is you make a flat surface, there's one set of mathematical rules where you're just counting all the stuff that, you're just counting the rays that come out in this direction. But if you make a round surface, then you're counting the rays in both directions. So one obviously will measure the field strength and have to divide it by the inverse square law because they're getting both fields, and the other one would be just the R thing. But the point is that you're just trying to take any big surface, collect the total charge, and then divide it over your surface. So it's just a way of measuring it indirectly by collecting it in a bag or in a surface. And so, again, it's just a way of acknowledging there's a certain amount of energy coming out of the wire or magnet. Even if they think your theory doesn't work because they're dumb, they should at least be able to see how it comes closer to the Holy Grail than theirs. Well, I mean, it obviously unifies. I mean, to say you could, I don't know how they can say it's broken in some catastrophic way, but I'm just saying that it obviously unifies. It obviously explains how something called gravity could be converted into something called magnetism, and how exactly the same force could be creating both phenomenon. It clearly does that. So, I mean, you can't deny that it unifies. Yeah, sometimes the answer is in the other PG of Google, not the first. Oh, that's for sure. Well worth the effort. Yeah. Blah, 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 blah. Yeah. Okay, so I'll give you a little more time so if anybody else has anything to say, and then I'll tuttle off. But again, I'm not opposed to mathematics. I clearly state I don't do calculus. I understand the math people are doing. I can understand some of the symbols. I mean, obviously the Einstein thing, they made up a bunch of bullshit symbols. I mean, they don't have any. I mean, you have to look them up. They're not symbols that have any overt, obvious meaning. And they just stand for another equation that has to be done and then placed into the equation you're doing. So, so I haven't made any statements that I'm a mathematician. I'm not. I'm doing physics. I'm doing mechanical stuff. I'm not doing a whole bunch of mathematical stuff, but I don't have any hostility towards math. I think the idea of formalizing relationships makes sense. I would argue that some relationships are complicated. So again, I'll argue that I don't think Einstein's field equations are actually correct in that he's using there's a lot of noise in his equation. His equation should be a much smaller equation. But because he contrived it to produce a result, that is, Mercury's orbit, it's got a lot of junk in it. Sorry if this is a bad question, but have you watched, I don't know what that is, but no, I haven't watched any kind of Evangelion. I don't do religion. I mean, I've probably seen something of it, and I said, oh, this is more idiots who have, religiousized physics. And it's like the electric universe loop-de-doers. They're not after the truth. They want a mystical solution to our existence. They're Dianetics, you know what I mean? They're Scientology. They're not playing an upright game. They're, attempting to defend a notion of hopeful love. The Loveverse. Yeah, I'll flip the piece of paper over just for fun. Give you a little bit of that fun stuff. And we'll go. Yeah, good stuff. Relaxed atoms, agitated atoms. Magnet, agitate atoms, polarize them, become magnet. More current, more agitated atoms, more magnetism. So simple. A gorilla could probably do it, but human, forget it. You are like the real life Shinji. Yeah. The real deal. We must all carry the diamonds in your head. I know what that means. Heads in our heads. We must carry the diamonds in our head. Demons in our heads. We all must carry the demons in our head. I don't know what that is, but I don't like religion, especially Buddhism. Life is suffering. Let's make more. Anyway, 30-second warning or something. Oakley doke. So till the next time, and and I probably do have to close this. Yeah, close. Thank you. Might as well see how many little peoples is here. 9. Ugh, pretty crappy. But such is the circumstance. Next time.